So let us discuss what is Makefile and how do we use Makefile to compile a program comprising of multiple .c and header files. Before getting to the Makefile, we notice func.c and main.c are there, and we start writing a Makefile. So what is a Makefile? Makefile comprises of something called rules, rule 1, rule 2, and ... What are these rules? Rules are basically how to build individual things. The first rule can be that main.o depends upon main.c. This is also called a dependency rule. Main.o depends on main.c, and when you press enter, the first character has to be tab here. Now I can write how to create the target if the dependency has changed. So I will say gcc -c main.c, and of course I can have that -wall and -g. Similarly, I will copy paste and I will create a rule for func. I will substitute main with func globally. So now my two rules are ready. The rule is simply saying that this target is dependent on this dependency, and if this dependency is more recent, that means the modification timestamp of main.c is greater than modification timestamp of main.o, then rebuild that target, create main.o afresh. What we need to now tell Make is how to create the output, the binary file. Let's say I'm calling the binary file output. So I will say output depends on main.o and func.o. gcc -o output main.o func.o. So this is the simple Makefile. Let me clean the extra lines. I do make and it is made. So this is how make works. It builds the ingredients. From main.c it builds main.o, from func.c it builds func.o, and then it builds the output. Every Makefile normally has a rule called clean. Clean rules look something like this. You say clean colon, there is no dependency. You say rm -f star.o and binary. When I do clean, this rm command will run. Once you have built, and if you do make again, it doesn't do anything because everything is up to date, because output is more recent than main.o and func.o, and main.o is more recent than main.c, and func.o is more recent than func.c. Let's say I modify main.c, which I can simulate by doing touch. Make will find that main.o is old and main.c is more recent, so it will recreate main.o. And once main.o is recreated, Make will understand that this output also needs to be recreated. So if I run Make, you can see that main.c is recompiled, and linking also happened again because main.o has changed, but you can notice that func.c was not recompiled. That is the benefit of Make, that it only compiles that part of the project which actually needs compilation. So there are more things about Makefile, like you can have macros. For example, you can say cc equal to gcc, and you can say something like flags equal to -g -w all, and then you can write stuff like this. You can say $cc, and same here. So basically these are called macros. Same flags have to be given to each .c file. So why write it every time? Why not define it at a central place so that if we have to add a flag, we can do it easily. This was a multi-file project. Sometimes we have multiple directories. So then we can always do something like this, that we can say ... /bin /main.o depends upon ... /obj /main.c src. And normally this looks a bit ugly, so one may define macros. Obj equal to ... /obj src equal to ... /src bin equal to ... /bin, and one can use those here. One can say $obj /main.o depends upon $src /main.c. Fundamentally, the only thing changes is instead of giving just file name, you are giving complete path. Otherwise, it remains the same mechanics.